Okay, hello everyone. This is Rod Stollmuller, and this is the Aviatrix Tech Talk Tuesday. We're in our 6th episode now, and we're moving on. We've got some really good content for you today. I'm joined by some of our top technical guys, Saad Mirza, Dana Yanch, and Hari Sankaran. So we have some guys that are out in the field talking to customers, doing a lot of architectural discussions every day, and they hear a lot of things that customers face. So today we're going to go into some of the details on how they're designing secure, high performance, next generation transit architectures. Just a little bit of housekeeping before we get going. If you have questions, please use the Q&A feature at the bottom of the panel to ask questions, and we'll try to answer some of those questions during the time that we have. So without any further ado, let me introduce Saad and Dana.
Yeah, thanks, Rod. Fantastic attendance we have here. We have a ton of people on this session, so this is really exciting. I'm going to have Saad kick it off, actually, and just a quick question for Saad. So I know that you've been at Aviatrix for a while now, and as a solutions architect, you're seeing the whole gamut of architectures. You're really in every single vertical and pretty much all sorts of organizations in all the clouds. And so I'm really curious what you've been seeing from the transit perspective in the cloud today.
Yeah, sure, Dana. So there are a few different ways how enterprises have built their transit designs. Believe it or not, there are still some enterprises without any transit. So basically, they are using native VPC or VNet peerings, even though they have hundreds and hundreds of VPCs and VNets. So let me discuss the legacy transit designs with everyone. Here I'm showing you the first one is basically about the native constructs. And what I'm showing you is the multi-cloud environment with Azure on the right and AWS on the left. Sometimes customer says we have only picked our public cloud of choice and we will always live there. This choice of public cloud is actually not a technical decision. In reality, business drives this. And we have seen this almost monthly, if not weekly, that enterprises who decided to stay in one cloud are now moving into the multi-cloud due to the business needs. So here on this slide, what I'm showing you with AWS, they have a native construct called TGW or Transit Gateway. You can attach the VPCs using the TGW attachment, and you will be able to communicate with each other, meaning the VPC should be able to communicate with each other. Same kind of approach is Azure. Azure has a spoke and hub model where you can utilize the native VNet peering between the spoke VNets and hub VNet. From the outside, it looks really nice and simple. But when you peel the onion, then you will find out there are lots of challenges. And the one challenge that I'm going to focus right now is about the route table management. So what is this? Let's double click on it. So over here, when you attach any VPC with the TGW, what TGW is going to do, TGW is going to learn the CIDR information of all these VPCs. But what TGW is not going to do in return, it's not going to propagate these routes back over to the other VPCs. So what I'm saying, if VPC 1 wants to communicate with VPC 2, that thing is not going to be possible, even with the TGW. You still have to write a static routes over here. So VPC 1 wants to communicate with VPC 2, you have to write a static route over here and point towards the TGW. Same thing in Azure. Azure calls the static routes as user-defined routes or UDR. So you have to write these UDRs over here. So just take a look at this. I'm only showing you 3 VPCs or 3 VNets right now. In enterprises, usually they have hundreds and thousands of VPCs and VNets. Is this approach scalable or not? And by the way, all this thing is dynamic in nature. So the CIDR which you have, tomorrow it's going to be a different one. You are going to add secondary CIDRs and secondary address space. This is all going to be manual and unmanageable approach. So the other issue comes in when you wanted to bring in the next generation firewalls. And very rightly so, because you wanted to make sure your entire public cloud environment is secure enough, right? You wanted to make sure your east-west traffic is secure, your north-south traffic is secure. When you are talking between the clouds, that is secure. When you are talking to your branches or partners or anyone, everything needs to be secured over here. So couple of different options available from the native cloud constructs. One of them is like native attachment. When you are doing the native attachment, then yes, you can get the full performance of the firewalls. If the firewall is providing you 10 gigs or 15 gigs of throughput, yes, you can get that. But one thing which you are not going to get is the same availability zone level redundancy. Both of these firewalls are in active standby, right? And then these active standby has to be in the same availability zone, right? And then on top, the manual routing, which I discussed previously, you have to write the static routes over here on the VPC level, and then you have to redirect the traffic when it hits the TGW. So you have to manipulate the routing at the TGW level as well. And there is no different in Azure environment as well, right? So what about this standby firewall, which is just sitting over there and doing nothing unless the active fails over to the standby? So you're paying higher costs for no reasons in this kind of model. So what these cloud providers have provided, they are saying, okay, we can provide you another model, which is active-active. Now you can have all active-active firewalls. But now what they are not telling you is now you have to attach the firewalls in such a way which can provide you an ECMP. In order for you to have the ECMP, basically you are looking for some routing protocol like BGP. And when you need to enable the BGP, you have to use IPsec over here. And of course, IPsec has its own baggage, meaning you cannot go beyond 500 megabits per second throughput, right? Because traffic is going to traverse twice. Even though this link is 1.25 gig, you have to divide it by 2 because the traffic is traversing twice. Another challenge with this approach is the visibility. If the application owners wants the 100% visibility of the source IP, that is not going to be available over here. And the reason is because you are enabling the source SNAT, which I'm describing it right over here. And the fact is, because that when the traffic is coming back to the firewalls, then TGW has to make a decision how to send the traffic, which firewall is going to receive the traffic. If SNAT is not enabled, then that is going to be a big challenge. So manual routing is still going to be the issue. Doesn't matter whether this is a this is the active-active or active standby. So again, whether you go with active standby or active-active, one thing which you are not going to get is the policy-based control on which VPCs are the entrusted VPC or protected VPCs. Meaning, if VPC 1 wants to communicate with the VPC 2, then only that kind of traffic should be inspected by the firewalls, not when VPC 2 wants to communicate with VPC 3. So that's called policy-based firewalling. That is not available over here. This model is either all or nothing. So just look at it over here in Azure. You are sending all the traffic to the firewalls, and sometimes this is unnecessary traffic, so you're overwhelming the firewalls. Some of the other things is about the common repeatable transit. This is a major one. Why? Because if you have a multi-cloud environment, right, like the one which I'm showing you over here, you started your cloud journey with AWS. Now the business requirement change. Business asks you, demands you to move into some other cloud like GCP, Azure, OCI, anything. You cannot take this TGW into Azure environment. And same thing with the Azure VNet peering. These VNet peering looks similar to the VPC peering over here, but they have different characteristics, different properties over here. So it's impossible to take the native constructs of one cloud into another cloud. And this actually common repeatable transit problem is going to magnify when you are going to have requirements from the business units like, hey, I have multiple business units and every business units want to manage their own infrastructure. They wanted to manage their own applications. They wanted to manage the firewall rules on their own. How are you going to do this thing in the native constructs? If you are in a single region, then you may be able to do this thing for a couple of business units. But what about if you wanted to have it for more than 4 business units, right? Because this native construct, which is called TGW, you cannot have it more than 4 TGWs in any region. And oftentimes, business units, while they wanted to control the infrastructure, they wanted to control the firewalling, they often want to have the communication across their cloud environment, like the black lines I'm showing you over here. Again, this is another big limitation of native cloud constructs. You cannot have this kind of connectivity within a single region. So what about the day 2 operations? So far, whatever I have talked to you, this is all day 1. Very critical because you are laying down your foundation over here, right? But the thing is, something that is going to live with you for the next 5 to 10 years, you need to operationalize that. You need to have the visibility across your multi-cloud environment, the visibility which you have never seen, or maybe you were expecting the cloud would never provide me this kind of visibility, so I have to live with that. But actually, in reality, the visibility should be in such a way that if application is misbehaving, or maybe application is configured improperly, the developer has write the code with the wrong port numbers, application should be able to provide that kind of visibility in seconds. It's not the other way around that you have to tell the developer and developer is going to take his time, maybe weeks or days to troubleshoot that environment. And how many times we have seen this thing that your application has been attacked from different parts of the world, even though you have no business. You wanted to know what those malicious IP addresses are. How can I protect myself? Sometimes you might want to allow that because there might be some business which you are not aware of. But most of the time you wanted to protect your environment by blocking those. So this kind of visibility is going to provide you that kind of flexibility as well. Also, I think most of you guys agree with this approach that your cloud IT usually gets the call like, hey, I have a multi-tier application and my tiers are spread across different VPCs and VNets. By the way, when I'm trying to reach my app tier from my web tier, it's not communicating well. What is going on? In order for you to do that kind of troubleshooting, you have to hit like 25 different data points. Like you have to know the instance name, you have to know the subnet, you have to know the routing table, you have to know the security groups and all that kind of thing. By the way, all those things are spread across multiple pages. So it's going to take you a lot of time to find out and map all that information. The architecture should be able to provide you and highlight you the entire path of the application. By the way, this is the path between these 2 tiers of the application. And by the way, this application, when it's going through this path, I'm noticing that kind of latency. And this latency information is extremely important for those latency sensitive applications, right? So the architecture should provide you that kind of troubleshooting techniques, which is missing, like packet captures, pings, the trace routes. Instead, the cloud providers are providing you this kind of object-based troubleshooting like a routing table, right? Just look at it, 10.10.00/16. How am I going to get there? Using this object ID. It's really difficult to understand. You need to map this thing first in order to troubleshoot. That is going to take hours of troubleshooting.
Yeah, this is great information, Saad. And I'm running into pretty much the same thing with my customers all day long. So I'm glad we're seeing the same thing in the field. But I'm also seeing alternative transit architectures using third-party solutions, although my customers haven't been that successful with those third-party solutions. I'm wondering what you've been seeing in the field.
Sure, Dana. So we are also seeing some third-party transits like the one I'm showing you over here. So one of the major asks by the customers are like, hey, I wanted to provide the firewalling, the inspection for my application. So the only thing they can think of is, why not I just provide the firewalls right here in the transit, right? The one I'm showing you in the Azure or maybe in the AWS environment. So they architect their design in such a way that they connect their transit with all the spokes using the native constructs. For AWS, they call it a VGW. For Azure, they call it the VPN gateway. And this thing is basically no different if you want to use something like virtual router-based transit, right? Pretty much the same architecture over here as well. So all the challenges that I discussed previously in native constructs, that is going to be applicable for this kind of architecture as well. Not only that, but since you are creating the IPsec between the transit and the spoke, that comes with the baggage, right? The baggage of low performance. Maximum throughput you can get is 1.25 gig. That's it. And by the way, your multi-region or multi-cloud connectivity is also limited to only 1.25 gigs over here. Since this is an IPsec over here, so basically you are running the BGP in IPsec. You have to manage it. This is a dynamic environment. You have to keep managing it. Day one, Lambda script does the job for you, but this is something which changes quite often, and you have to own it. You have to manage, which is very, very complex. Again, since you are doing the BGP over here, so, which means it's going to be a huge blast radius. And oftentimes that not every VPC wants to see the VPC, other VPC or VNet's IP's address space or siren information. That has to be blocked.
Yeah, so a ton of challenges, a lot of inefficiencies, and I'm sure a lot of people on the call have come across this as well, and I have myself. So there's a solution though, and I know what I'm using for my customers. Just want to see what you're doing out there for all the different customers you're working with right now, Saad.
Sure, Dana. So, to be very honest, the solution is pretty simple. All we have to do is to pick the right transit. Transit is not only where you are connecting your spokes, you're actually also connecting your on-prem, your partners, your branches, remote users, multi-regions, and multi-clouds. So this is becoming your backbone of the architecture. If this is done right, then everything is fine. A transit that can repeat itself across multi-region and multi-cloud, like the one which I'm showing you on this particular slide. Just take a look at this thing on the left-hand side of the picture. That's AWS, right? Over here, every spoke has Aviatrix gateways. Transit has Aviatrix gateway. The on-prem has Aviatrix gateways over here. If you deploy this kind of architecture, then you are getting double security. You are secure using the encryption. You're also secure using the next generation firewalls over here. And just look at this entire architecture. It's repeatable. You don't really have to worry about it whether you are going to spin a new environment in OCI or maybe in GCP. Right now, I'm showing you Azure. It's exactly the same architecture over here, same gateways in spoke and transit. Now, the point is, what about if there are multiple BUs? They wanted to control their own environment, like the challenge which I showed you previously in native constructs. This challenge is no more a challenge in this kind of architecture because you can repeat this architecture as many times as you want. Like hundreds of BUs can be in the same region. They can control their own firewall rules. They can manage their own application and infrastructure. And look at the flexibility over here. Some of the business units might not even need the next generation firewall. This architecture can provide you that kind of flexibility. And when these business units want to communicate within a region, in multi-region, or maybe in multi-cloud environment, all you have to do is to just connect them together using transit connectivity, right? And for times like these, where everybody is working remotely, right? So you wanted to make sure your partners can access the cloud environment. Your contractor can only access the resources which he's responsible for him. An employee, since he's an employee, he should have access to all the resources over there. This can be achieved only through policy-based VPN using some SAML-based kinds and stuff, right? And there are customers and enterprises who have invested in SD-WAN. The architecture should provide you simple and elegant way of connecting the SD-WAN world to the cloud world, like the one I'm showing you over here, provided that everything remain end-to-end segmented. So this is, again, all day one, which is extremely important. And then you have to know whether you can operationalize this or not, right? So this thing, you can do it for 1 or 2 times. You like to do it using the UI, but for enterprises, they want to do this thing in a programmatic way, like Terraform and APIs. That is all supported in this architecture. Not only that, you can bring in any vendor of your choice for firewalling, like Fortinet, Checkpoint, Palo Altos, even the same thing for logging services like Splunk or Datadog, Sumo Logic. And then the unprecedented visibility that I discussed previously, which can provide you the visibility, like you can configure, you can view, or you can troubleshoot in seconds. That is being provided by Aviatrix controllers and Copilot. So Dana, these are some of the common challenges that I have noticed working with my customer. And I know you have a very good, solid, routing background. What kind of challenges have you noticed working with your customer?
Yeah, sure. Let me share my screen real quick here, and we will talk about that. All right, cool. Hopefully you guys can all see that. Yeah, you're right. So my background is in routing. I spent the last 10 years focused on routing and other software-defined architectures. And so naturally coming over to cloud networking, I started concentrating on the routing side of things and working with customers that were having routing challenges. And there's a lot of them. There's a ton of them that we've identified and that we've solved for. But let's just high level talk about some of those challenges and what we're seeing in the field. And I'm sure you're seeing the same thing. And you actually talked to some of these at a high level. So just level set here. Here's a little example of a common architecture that we see in the field all the time here these days. So in this case, it's AWS, but this could be Azure, GCP, OCI. It doesn't matter. The concepts are the same. And in this case, you might have a generic transit environment with VPCs hanging off of it. And you might have a TGW, transit gateway type solution in there as well, interconnected with its own VPCs hanging off of it. Maybe you have some east-west security firewall VPCs, some north-south security VPCs in there. Maybe it's a third-party connectivity VPC. Likely you have a direct connect or an express router at minimum a VPN with BGP in there down to on-prem. And maybe you're even integrating SD-WAN if you've gone that far. So in that case, you have really all these native constructs being used. But the truth of the matter here is that they're all static. And that's a problem, right? So maybe if you have like 3-4 VPCs, small environment, static is not that big of a deal. But that's not going to be the case for most organizations. I would say 99% of the organizations are going to grow this out as they start to realize how easy it is to consume and how flexible it is to consume the cloud. And then you start to scale it out to multiple regions, and then that scales out to multiple clouds, and it starts to get really ridiculous to manage. I don't know about you guys, but I don't want to spend the rest of my career managing static routes and handling it, troubleshooting in a static fashion. It doesn't make sense. We didn't do that in the past. We shouldn't be doing that going forward, right? So static is a big issue here. It's a big problem for scale and manageability. In addition to that, we're starting to see that cloud native solutions have a lot of scale limitations around route table entries, equal cost multipath. So an example of this for route table is if you're terminating the BGP in the cloud on a native construct, you're not going to get any type of route scale, any type of real enterprise route scale. It's pretty minimal. It's going to force you to do summarization. Sometimes where you don't want to do summarization, maybe you want to have some more specific prefixes in there. And we're seeing a lot of customers get upset at this. And they're causing outages because they're injecting too many routes, or they're just hitting limitations in flexibility. And so that's a issue. We can't have any limitations around there. Just because we're moving to the cloud doesn't mean we have to compromise on our flexibility and our functionality that we had on-prem. It doesn't make sense. And so another issue here we see is equal cost multipath routing. Native constructs either don't support ECMP, or if they do, it's pretty minimal in how many paths they support, maybe 2, maybe 4 at best. So you're hitting scenarios here where it's hard to scale out with equal cost multipath routing. You have an active standby scenario where it's slower to fail over. You don't have a nice, highly available, highly horizontally scalable solution to grow out. And so we want that same functionality. It's a big issue today. Even bigger is that there's no traffic engineering. There's really, it's kind of dumb, right? The native routing in these environments is very, very basic. So you don't really have the tools that you had on-prem that we're used to dealing with for traffic engineering that we're starting to see now as we get more and more ingress and egresses out of the cloud, different ways to access the cloud, different on-prem connectivities, different peering connections with Equinix and partners and other data centers. It starts to get ridiculous, and you need some way to handle traffic engineering like we had on-prem with BGP, right? You want to be able to manipulate AS path and do prepending and maybe local pref or med or something like that to manipulate how traffic is taking different transit paths in the environment and make sure that you're picking the most optimal path at all the time, right? So that's a big issue. It's a big, well, I'm seeing that all day long. And other problems that, like I said, these environments are dumb. Like there's no intelligence at all. There's no best path algorithm. There's no loop prevention built in. There's no graceful failover. It's all very static again. It's all based off the user intervention. And so that's an issue, right? As you start to scale out your network and you have multiple ingresses, different points of redistribution in the network, in and out of the cloud, different peering points, different clouds, then you're going to run into a scenario where you need to handle best path manipulation. You're going to have to deal with loop prevention, and you don't want to do this manually all day long. And you're going to want to have a way to have graceful failover. So if a region goes down or connectivity to a region goes down, there should be a deterministic automated failover fashion where routes are reprogrammed, paths are reestablished, reconverged, and traffic takes the next best optimal path into the cloud to reach that resource that was no longer available via the original local link, right? So you have to have intelligence there for that to occur so that it happens in a timely fashion and that it happens deterministically and that you have full control over it, right? We're all familiar with that, like BGP routing, OSPF routing, EIGRP routing, and all the tools that we have on-prem. We need that in the cloud as well. But it's a balancing act, right? The goal here is to do that with simplicity. You don't want to add a bunch of complexity to the cloud, right? That's going to be making our lives harder. We want to have the dynamic nature of routing and the dynamic nature of the enterprise networking in the cloud, but keep the simplicity, remove the complexity. And so with that, you need to ensure that we have visibility and control. Today, there's no visibility. You don't understand why these black boxes that run under the covers and your cloud service providers do what they do from the routing perspective. And when they don't do what you're doing, it's hard to figure out why they're not doing that. It's not giving you any feedback. There's no feedback as to, well, what's the reason this is happening? How do I dive into it to figure out why this is happening? You don't have that visibility. They don't give it to you, and they probably never will. It's just not their game. And so it's going to be difficult to have a real enterprise network functionality in the cloud as you start to bring more and get more complex and more functionality out there. You want to have control as well. You're missing control. You see that I threw BGP on the map here now too, because you have BGP to on-prem, BGP to SD-WAN pods, and BGP to a partner. You need to control what routes are coming in and out. You need to control how those routes are advertised. You want to be able to filter. You want to be able to summarize. You want to be able to do everything you've been doing in the past. You need those tools in your tool belt to be an effective network cloud architect. Guarantee it. So here's a little example of what happens when you do native routing and you scale this out to multiple clouds. So this is 2 regions. So you can see this is static as everywhere. And I only have like 5 VPCs on here, maybe 8 at most. That's not the case for most customers. We have customers at Aviatrix with thousands of VPCs, thousands across multiple multiple regions and in multiple clouds. And so imagine doing all of that static, and then you throw in a peering relationship in between there, and you have additional paths to deal with, which are also static. And then you have multiple data centers that are ingressing, egressing the cloud via their regional connectivity. A lot of times those data centers have a direct connect, or sorry, a DCI, well, they have a direct connect and maybe an express route to the cloud, but they also have a DCI between each other. So now you have multiple paths, and you have places where loops can occur and suboptimal routing can occur. And so you need to figure out a way to not have this complexity and make this more dynamic. One thing to note here is that when you run BGP to the cloud, yeah, it's dynamic. But once it hits the cloud, it becomes dumb. That's it. You lose everything. You lose all your visibility, all the AS pathing, everything that you're doing downstream in your environment to do filtering and tagging and all that mechanisms. They're all gone once they hit the cloud. You're back to basically kind of a dumb router environment. So it just doesn't. Then you need intelligence, right? So it's a big issue. So how do we solve this? Well, this is what the solution is all about, right? Aviatrix has spent the last 4-5 years on 6 major releases of their code to build a control plane for the cloud. So we built a unified control plane and a normalized data plane across all the clouds and all the regions to add this intelligence, to add the dynamic nature of things. And so you can see this controller now is intelligent, and it's got connectivity into all the cloud constructs. It's monitoring and it's learning in a dynamic fashion, and it's programming things in a dynamic fashion. So it's got connectivity to all your clouds via APIs. It's monitoring as new CIDRs are added and new CIDRs are removed. And so that allows us to be dynamic in nature. So if you spin up a new VPC via automation, or however you guys spin up VPCs, if you do it the old-fashioned way via the console, you can do that. But the moment you attach a CIDR to a transit environment, to a TGW, the controller learns it. The controller propagates that CIDR end to end. It programs the route, and every VPC, and every TGW, and every attachment, and every BGP peering, wherever it needs to be for that application traffic to get from point A to point B. It figures that out for you, and it's dynamic. If it detects that route disappeared, maybe it was pulled out of a BGP advertisement, or maybe the CIDR disappeared or the VPC was deleted, or whatever it is, Aviatrix controller recognizes that, pulls it out of the mix so that you don't have any black holing occurring. All automated, no user intervention, all monitored with full visibility. This is done for you. It's pretty fantastic. So on top of that, we handle the large route table problem, because now you're terminating these peerings on our gateways, which are just powerful Linux routers with a lot of enterprise functionality built into them, and the automation and the controller SDN connectivity to the controller. You now have pretty much, I wouldn't say a limited route space, but you're going to get into the hundreds of thousands of routes in the table that it can support. So it's not going to be a problem for almost every organization after that. And these controllers are smart enough to summarize and to advertise only RFC 1918, or to only advertise default routes wherever that needs to happen, so that we don't overwhelm your cloud native constructs. So we'll have the more intelligent, the higher route table in our environment, in our gateways, where they need to be for best path decision making, but where they don't need to be, it'll automatically do the filtering, it'll automatically do the summarization and the RFC 1918 address space advertisement for you. It's really beautiful. On top of that, we have full equal cost multipath routing everywhere. No limitation there. Think about it. Now you can do equal cost multipath from VPC to VPC, VPC to transit, transit to on-prem, transit to partner, transit to SD-WAN. It really doesn't matter, because the gateways don't have that limitation as to how many paths can be terminated on that gateway, right? So now you can have 26, 30 different equal cost multipath tunnels, and you can load share across all of them to get higher scale, faster failover. Really things that you were used to doing on-prem. Remember Ether channel? Remember lags? LACP is the same thing, right? You get the same flow sharing across multiple transports and multiple tunnels, I should say. So then we get the intelligence. We get some more traffic engineering functionality. I kind of mentioned that already, but in the cloud, you can manipulate how routes are advertised from cloud component to cloud component, or gateway to gateway, using Aviatrix controller policy in the UI or via Terraform API, or however you want to manipulate it. So you can now manipulate the best path algorithm in the cloud based on what you want to do. So if you want traffic to ingress the east and go out the west, or ingress the east and go out a partner, or whatever you're trying to do, manipulate the traffic, you have the tools to do that. On top of that, you have BGP traffic engineering support now. Because you're terminating BGP on the Aviatrix transits and we run the BGP stack, you can now maybe do things like, maybe you might want to do AS path prepending, right? Pretty common thing. So we can now do AS path prepending. We can have actual BGP best path calculation that you're used to doing from your last 30 years of your career, or however long you've been in the industry. We can also do summarization now in strategic places in the network. So we get the controller intelligence, best path, loop prevention. Of course, there's loop prevention now because the controller knows where loops will occur, and it'll block the advertisement of a route where it thinks a loop would occur. Pretty common scenario. You might have multiple data centers, multiple ingress egress points, a transit in between, a DCI downstream. You're going to have a looping scenario. So it'll block where it needs to block intelligently. It'll support the highly available failover architectures, so graceful failover between regions, reprogram routes so that you still have access to a region that was no longer available because you lost the local access to that region. And it's also constantly auditing routing, making sure that the routes haven't changed, nobody's gone in there and messed with it, nobody's pushed an API via some external entity to change the routing. It's going to audit that and give you alerts. We've now fully exposed the route tables. You can see BGP went green because now we carry the BGP intelligence and you have full BGP visibility in the cloud. So we expose the full route table, everything, the BGP best path algorithm, decision-making. You can do route filtering as it ingresses the cloud, and you have end-to-end route visibility here. So here's how it looks on the grand scheme of things. You have an Aviatrix controller at the top. It's kind of like the god of the cloud networking. It's connected to all the constructs, whether they're native or Aviatrix constructs, even peering relationships between cloud environments. And it's monitoring all the routing, it's doing all the programming, everything I talked about here. And now BGP is intelligent. That's why it's green, because I'm able to carry that information, make decisions in a more intelligent fashion. Really nice architecture. It works brilliantly for, I think we have over 450 customers now leveraging this multi-cloud network architecture with our controller and really benefiting from it. So here's some examples of route visibility. You can see here that you have BGP, you have show IP BGP. You're all familiar with that. I'm sure you've all seen that. Show IP BGP summary. All those BGP commands are used to using, advertise neighbors, all that stuff. You're going to be able to run that in here and get better understanding of what the heck is happening in the cloud and why it's happening from the path decision perspective. And because the controller has an audit and understanding of everything that's going on in the cloud native pieces, it can also pull all the VPC route table information, TGW route table information, TGW attachment information, and present that to you in the UI or via API, and you can leverage that however you want for whatever functionality you're trying to leverage it for. But you have one place to go now, not a million windows to open across multiple different cloud subscriptions or accounts and regions. You have one place to look at all that and handle it all from the UI. Also, our gateways provide you a full visibility in the route table, as you can see down there in the bottom of the screen. So we also have full route control and validation. I love this validation functionality in the solution. It saves me so much time when I'm troubleshooting customers' environments. And so we have this feature, this tool called Flight Path. And Flight Path runs a report on the cloud native as well as the Aviatrix components of the solution to look at every single decision-making process in the network. So it'll look at route tables on the TGW, on the VPCs, on the Aviatrix gateways. It'll look at security group entries. It'll look at NACLs. It'll look at peering information. Right? It tells you everything end to end. It tells you, you just pick the source and destination IP or instance and region or VPC or cloud, and it will tell you exactly, hey, here's where you're missing. You're missing this route. You missed the 172.116.32.0 whatever /24 route. That's why you can't get through in this construct. And so you can go in there and fix that or whatever you need to do. But it really will determine exactly the line item that's breaking your traffic flow. So it's a lot of good validation there. On top of that, we have a route control. So as routes are learned from the partners or extranets, or you're on-prem, we can filter them out before they get sent anywhere. This is unprecedented control in the cloud. You didn't have this functionality when peering with BGP in the cloud. You just took it all on, right? You had no control there. And so if you're connected to a partner and that partner sends you an overlapping CIDR or sends you a default route or sends you a more specific prefix and that messes up your cloud routing, that's your fault, right? You can't do anything about it because you don't have access to the partner's equipment to filter out, right? So you have to have some way as it ingresses your environment to filter. And that's what we provide you this support for. All right, so Saad, there's another thing I run around, come across, I should say, in the cloud, and it's not specifically routing. It's more around overlapping CIDRs. So as organizations are moving more into the cloud, they're realizing, hey, we can also move our partner connectivity or extranet connectivity into the cloud as well. It's cheaper, it's more flexible, it's more optimal. It makes more sense from a management perspective. And so then they're running into these problems where they're having overlapping CIDR, right? So everybody uses RFC 1918 space in the industry. A lot of people use 10net. And so you're going to come across a scenario where you have overlapping CIDRs and you got to deal with it. And how do we deal with this in the past? NAT, right? Source NAT, destination NAT. We had NAT tools on firewalls, on routers, pretty much everything supported NAT, except the cloud. The cloud from day one never supported NAT. I don't know why. It's just no support for NAT. Kind of a pain in the butt because you need NAT in a lot of places. NAT's not going away anytime soon. And so in this case, we have 10.1/16, 10.2/16 in my cloud environment, but I'm connected to a partner and they're also running 10.1, 10.2. And I need those two environments to talk to each other. It's going to conflict. It's not going to work. So you need to use something like NAT and put a gateway in place. And so since you're leveraging the Aviatrix multi-cloud network architecture, where there's already gateways in strategic places in the network, you have all the flexibility now to place NAT and all types of NAT on the spoke and on the transits. And so you have the flexibility to do the translation where you need to do the translation in an optimal fashion so they can talk to each other now. And it's really simple to configure. As you can see in this diagram, it's like anybody can figure that out. It's just like configuring NAT on any other box. Very, very straightforward. So lastly, last thing I want to talk about here is I'm running into relatively new requirement where organizations need full end-to-end encryption. And Saad, you talked about this a little bit, but this end-to-end encryption requirement is becoming real. We have hospitals and we have the Department of Defense and other organizations that require end-to-end encryption for data in flight. And when they do this manually, first of all, it's a pain in the butt to do it manually. Number two, you lose the performance. You can't get the equal cost multipath encrypted transits or encrypted paths that they need. They get knocked down to 1.25 gig, right? It's not going to work in the grand scheme of things in the larger scale of networking. So Aviatrix, of course, has solved that problem. We've solved this for a long time, and our customers are leveraging this today. And so the spoke to transit VPC connectivity or spoke to spoke, you can get up to 75 gig of intra cloud connectivity. From on-prem to transit or transit to on-prem, you can get 10 gig plus. That's 10 gig encrypted transit line rate over direct connect. And you can get even more if you have a higher bandwidth internet connection on both sides. And so you can get some pretty nice connectivity in and out. Then if you're doing from cloud to cloud, like AWS to Azure, AWS to OCI, you can get 5 gig. And that's unprecedented because in the past, people would be stuck at 1.25 gig. But the 5 gig limitation here is not us at Aviatrix. We can, like I showed you, up to 75 gig, multiple tunnels. But the problem is that the cloud service providers, their IGWs, their internet gateways, really only support about 5 gig aggregate throughput. So it makes it difficult to go past that. But you're building a future-proof solution, a future-proof architecture when you leverage Aviatrix, because once they do raise that limit, it'll automatically start to grow. It'll grow to your higher throughput level. It's pretty fantastic. How do we accomplish this? Let's go through it real quick. It's also pretty straightforward. We're the first in the industry to do this, and I'm sure people are going to start catch up and do the same thing. But we're doing high performance encryption using multiple tunnels tied to multiple cores. And these multiple cores are the dedicated processor for these tunnels. And so we can tie flows to cores and do this over many tunnels. And then when you have multiple boxes on each side, you can have an active, we call it active mesh of tunnels, and we can load the flows across all of these different tunnels and get super high throughput, right? If you want to go a little bit deeper, you can see how that's built, right? You have a box on the left, a box on the right. These instances might have 16, 20, 30 different CPUs. We'll build a dedicated tunnel for all of these CPUs, tie the traffic to a dedicated CPU, and then we'll get this high performance encryption tunnel across these two environments. It's really powerful. And that's really all I wanted to show you guys today.
All right, awesome. Guys, you covered it in very, very deep detail, I think on a lot of good points here. And so for anybody that's listening and wants to go the next level or has some questions, let's get together and we can drill in. I'd like you to answer this poll if you can while we're addressing some of the questions that came across so that we have some feedback from you guys. But just a couple of questions since we might have a few minutes here. One of the questions that came across, and maybe you guys can address, is for an AWS customer who's already using TGW, or their transit gateway. What's the pros and cons of integrating the Aviatrix transit with that versus just doing standalone Aviatrix transit? Maybe you guys can hit a couple of points on that real quick.
Yes. So basically, the one thing and the most important thing over here is you cannot get the repeatable architecture over here, right? So you cannot get the TGW in Azure, GCP, or OCI environment. And again, the things which I talked about it earlier, like if you wanted to spin 3 or 4 or 5 different business units in the same region, that would be a problem when you wanted to communicate between each other. You cannot even have more than 5 business units in the same region because there is a limit of having only 5 TGWs in there. On top, then you will lost all the visibility, right? The troubleshooting becomes real disaster. Your tier 3 will always become tier 1 for you. The reason why? Because you lost all your common troubleshooting tools, which I discussed previously, like the pings, the trace route, the trace path, the traffic captures. All these things are not available using the TGW.
Okay.
Did I answer the question?
Yeah, that was good. There was a follow-up question to that about Azure. So, can the transit, can we utilize the virtual WAN hub in Azure connecting to the transit, our transit?
Yeah, so Azure has multiple ways, like multiple transits over there. One of them is the virtual WAN. They do have NVA kind of transit as well. And they do have something using the MSEE, which they usually don't, document it pretty well. So multiple options are available, but every single option has a lot of challenges, which we have already discussed. If there is anything specific you guys wanted to ask us, then please send us an email. Like my email is saad@aviatrix.com, or if you wanted to send it to the info@aviatrix.com, we can take it from there.
Yeah, I'm sorry, guys. I think we've reached our time limit. We're about 5 minutes over. So absolutely, as Saad said, let's go ahead and send us an email if there's any questions that you have. And you can see on this slide, we've got more Tech Talk Tuesdays coming up. So sign up for those. And if you have any subjects you'd like to cover in future Tech Talk Tuesdays, please send that to info@aviatrix.com as well. Thank you all for being here, and we'll see you next Tuesday.